Hello. We are about to do multiplying with fractions. So we have, at this point, you've probably watched the videos for adding and subtracting fractions with like denominators, with unlike denominators. We've talked about the fact that you need to have common denominators in order to be able to add and subtract fractions because the pieces have to be the same size. So what we're going to do now is talk about multiplying and dividing fractions. And we can basically do it all at once because multiplying and dividing fractions is easier. So we're just going to do a couple, and then we'll pull a couple out of the Kaplan book. If you're going to be using your Kaplan book, I have mine right here, and we're talking about being on page 248. At least in this edition, it's 248. It's section 4. And there's plenty of practice problems in there and answers in the back. So we'll do a couple of those also, just to make sure that you have some examples directly out of your book. So what do you do when you're multiplying fractions? Well, the first thing that you have to understand is you're taking a part of something. So a fraction is always somewhere between 0 and 1 on the number line. Okay, so if this is 1 and this is 0, and say you're here, you're at about a half. You're about halfway. Here would be maybe 3/4. Maybe down here would be like maybe 1/5, something like that. But when you're multiplying a fraction, you're taking a fraction of something that is less than 1. So you're actually going to get a number that's smaller than you started with. Think of how regular multiplication works. If I take let's say 2 times 5 people on a basketball team. So I take 2 times 5. I have this many times. So 2 of 5 teams, I have 10 people. No problem, right? But let's say I have a team of those 10 people. If I take half of 10 people, well, half of 10 people is 5. Because I'm taking less than 1 of something. So the problem's on this page, and we'll do the first one. If you take a half of 3/5, 3/5, you can kind of, imagine what that would look like. That would be something that's divided into 5 pieces, and you have 3 of them. Like we talked about in fractions, you have 1, 2, 3 pieces, but you're taking half of that. So half of that is not more than that, it's less. So how does it work? In fraction multiplication, it's really very simple. You're going to multiply the numerator times the numerator, and the denominator times the denominator. If you can reduce before you do it, it's a good idea to do that first. But for right now, we would just do the 1 times the 3, and we would get 3. Do the 2 times the 5, and we would get 10. And 1/2 of 3/5 is equal to 3/10. And that's it. There's no common denominators. The only thing we have to worry about is reducing if possible. Let's try another one of these. So 3/4 is a fraction that we're pretty familiar with because we know how much money 3/4 is, right? It's 75 cents or 75% of a dollar. So if I've got 5 pieces out of 6, and I take 3/4 of those, I'm taking about 75% of that. It's still going to be a little smaller. Now, in this case, you might notice we have a top number and a bottom number that share a common factor. One way to think about this as this is really 3 times 5 on top and 4 times 6 on the bottom. What this means is if you have a top number and a bottom number that share a factor, in this case 3, because 3 divides by 3 and 6 divides by 3, you can do that before you multiply. And I'm going to do it both ways. So first I'm going to multiply without reducing, and I would get 15 over 24. Now if I have 15 over 24, pull that down a little bit. If I have 15 over 24, then I need to reduce. I look at my 15, I look at my 24, and I say, I think we can probably divide both those numbers by 3. So 15 divided by 3 is 5. 24 divided by 3 is 8. And the answer is going to be 5/8. And that's our final answer. We could have done this here though, because right here we have a 3 and a 6, and they both divide by 3. So that would have become a 1, and that would have become a 3. No, let me wind that back a little bit. There's an easy mistake to make. 3 divided by 3 is 1. 6 divided by 3 is not 3, it is 2. So 1 times 5 is 5. 4 times 2 is 8. So it doesn't matter when we do it, but this is easier to do it here than to wait until we've made the numbers really big. And our answer is 5/8. And it works this way, whether you have a fraction times a fraction or even 3 fractions. So here we have 5/7 times 4/5 times 1/2. So 5/7 of 4/5 of 1/2, just a bunch of fractions multiplied together, but we can reduce before we multiply. So instead of getting 20 over, 70 or something like that, we can say, look, we have a 5 on the top and a 5 on the bottom. They both become 1, which means they're not going to do anything. 4 divides by 2 and becomes 2, and 2 divides by 2 and becomes 1. And now we've got 1 times 2 times 1, which is 2, and 7 times 1 times 1, which is 7. And we're done. 2/7 is our answer. Now that's it for just regular fractions times regular fractions. Numerator times numerator, denominator times denominator. Reduce if possible, preferably before you multiply. But there's some other things that we're going to deal with. And this is talking about the same thing that we just did, which is reducing before you multiply, because you definitely should. So we're going to skip past that. What do you do if you have a whole number? Well, remember what I said about if you take a fraction of something, you're going to get less than the whole thing. Let's try taking 2/3 of 10. Now, I'm not sure what comes in a pack of 10, but let's say again, you got 10 kids, right? Boy, I hope they're not all yours. Anyway, you have 10 kids and you want 2/3 of them. Somebody says, hey, take about 2/3 of those kids. They need to go out to recess or something. All right, well, how can you go numerator times numerator and denominator times denominator if there isn't a numerator and a denominator, a top and a bottom number? Well, the number 10 is the same as 10 over 1. So you just put it over 1, and now you have a numerator, you have a denominator. 2 times 10 is 20. 3 times 1 is 3. And now you have an improper fraction. So you need to go ahead and do 20 divided by 3, or how many times can you take 3 out of 20? And that's going to be 6 times, or again, to make a fraction into proper fraction, you can just do 20 divided by 3. So 6 times 3 is 18. Subtract, get 2. That's your numerator, 2. 3 on the bottom. And it's 6 2/3, which is less than 10. Because again, you only took 2/3 of 10. So you're taking less than the whole thing. So it makes sense that it's a smaller number than 10 was. We'll try one more of these just to make sure we've got the right idea. So let's try 3/5 of 6. 3/5 times 6. First step, you're going to make that a fraction. It's really easy. Just throw a 1 underneath it. 6 over 1 is 6. Now, 6, 5, 3. These two share a common factor. Can we divide them both by 3? No, because it has to be a top number and a bottom number that divide by the same thing. And 5 and 3 don't work, and 6 and 3 don't work, and 1 doesn't do anything. So you're just going to go ahead and multiply. 6 times 3, 3 times 6 is 18. 5 times 1 is 5. How many groups of 5 can we get out of 18? Well, you can do 3. 3 times 5 is 15. Then you'd have 3 left over. And 5. Again, 18 divide by 5. 3 times 5 is 15. Subtract, get 3. That is your numerator. The 5 is your denominator. 3 3/5. Okay. So we've done fraction times a fraction and fraction times a whole number. Let's try the next thing. What if the numbers are mixed? And I have some actual practice problems here. So you are welcome to pause the video. Try this on your own, see what you get, and then we'll do it together. You can just unpause me. The miracle of modern technology. Okay. You may have paused me, you may not. You may have tried this, you may not. Here's the trick with this. When we multiply fractions, we only want a numerator and a denominator. That's it. So we have 7 1/3 times 9. Well, 9's easy. We can just make that 9/1. But how do you make this into a numerator and a denominator and get rid of the whole number? Well, it's not going to be too hard. We're going to do the opposite of what we did back here. Oh, I already deleted it. We're going to do the opposite. So instead of the top number divided by the bottom number, we're now going to do the opposite of this. We're going to take the bottom number times the whole number. So 3 times 7. Because if you have 7 things that are cut into 3 pieces each, then 3 times 7 is how many pieces this represents, which is 21. Then you have this other piece here. So we're going to go 3 times 7 plus the one that's on top. So that's 21 plus 1 is 22/3. That is an awful looking 2. 22/3. That's much better. Now it's a bad 3. Times 9/1. Okay, well, can we reduce? Because if we can, we want to. And yes, we can. So these both divide by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. Now we go top times top. 22 times 3 is 66. 1 times 1 is 1. And 66/1 is 66, which is letter D. All right. So the thing we're adding here is making our proper fractions improper. You definitely want to be able to do this. This is important. So we're going to try 1 or 2 more of these. This time they are both going to have, oh, I might need to pull out a calculator for this one. It's going to be a big number. It's okay. So you have 5 1/2 times 18 5/6. So 5 1/2 times 18 5/6. Okay, make them improper. So 2 times 5 is 10 plus 1 is 11. So 11/2 times 6 times 18. Whew, calculator time. And remember, most of the tests, as a matter of fact, I believe in the HISET, you get to use a calculator for pretty much all of it. So you're going to want to get good with your calculator. So 6 times 18 is 108 plus 5. 108 plus 5 is 113/6. Now looking at this, I already know 11 is a prime. 113 is not going to divide by 2. It's not going to divide by 3. And it's not going to divide by 6. So again, calculator, 11 times 113. Don't waste time. Use your calculator. You got 1,243 divided by 12. Now, the best way to do this is on a calculator. If you type this in using the numerator denominator key, and this is something I can show you in person, you can just type this in, hit a key, and it'll automatically make it proper for you. However, we are not going to do that. We're going to write it out as long division. 1,243 divided by 12. Well, that's going to go in 1 time. 1 times 12 is 12. Now that worked out well. You bring down a 0. You bring down your 4. Can I take a 12 out of a 4? No. So put a 0. I bring down the 3. How many times can 12 go into 43? Well, 12 times 1 is 12, times 2 is 24, times 3 is 36, times 4 is 48. It's too much. So times 3, 103. Now at this point, we could just circle it and be done, but let's finish it. 3 times 12 is 36. 43 minus 36, borrow, becomes a 3, that becomes a 13. 13 minus 6 is 7. That is your top number. 12 is your bottom number, and you get 103 7/12, which is right there. Okay, so that's how we're going to deal with multiplying with whole numbers. Moving forward, all we have left to do is division. And as you can see, hopefully already, multiplying is easier than adding because we don't need to worry about common denominators. So there is a big part of this. And what we're going to do is we're going to use a little bit of pizza math here just to figure this out. So let's say you've got 3 pizzas. I'm sorry if your food is not good right now, that you got to look at this picture, but you know, is what it is. You have 3 pizzas. You want to make sure everybody gets a quarter of a pizza. How many people can you feed? So if you have 3 pizzas and you're dividing it into quarters, well, I mean, we already know what this is, right? 3 pizzas divided into quarters. We could take a circle. We could do this without using any numbers. We could just divide this into 4 pieces, divide it into quarters. We have 3 of those. Well, if I've got 3 of those, copy, paste. Oh, come on. Oh no. Let's undo that. Let's undo that. Let's try this again. Copy, paste. There we go. Copy, paste. Hey, come on now. There we go. All right, there's our 3 pizzas. We divided into quarters. How many pieces do we have? We got 1, 2, 3, 4. Second pizza, 5, 6, 7, 8 quarters. 9, 10, 11. We have 12 quarters. We know the answer is 12. What's the problem? Well, the problem is, what do we multiply by the bottom? No. Here's what you do. If you have a division by a fraction problem, you're simply going to change it to multiplication, because dividing by fourths is the same as multiplying by that same fraction upside down. Okay, the word for that is invert, right here, I-N-V-E-R-T. So you invert and you multiply. You just don't divide. You take that second fraction, you flip it upside down, and you change it from division to multiplying. Okay, so this would be 3, and this, of course, is 3 over 1. 3 times 4 is 12. 1 times 1 is 1, and that gives us the 12 pieces that we already knew that we had. So let's take a look at this with the real problems. So step 1, with division, you're going to keep the first fraction the same. You're going to invert. All right, so the word for this is invert, or flip the second fraction. You're going to change the division sign to multiplication. So we use KFC here for keep, flip, change to help us remember what we're doing when we divide by fractions. So I'm now going to pull a couple of these out of the textbook, or the Kaplan book. So we've got problem. It looks like we've got a number 10. It is 7/8 divided by 1/16. So this is number 10 in the Kaplan book on page 249. Number 10. And we have 7/8 divided by 1/16. Okay, so in your head, what you should be thinking about with this is if you have 7/8 of a pizza and you're dividing them into pieces that are 1/16 big, okay, that's going to be a decent number of pieces that you're going to get. So let's do the keep part. There, I kept the first one the same. That's your keep. Now we're going to flip. 1/16 becomes 16 over 1. Now we're going to change it. KFC, keep, flip, change, Kentucky Fried Chicken. We're going to keep, flip, change, and we're going to change this to multiplication. Now that it's multiplication, I'm just going to go ahead and erase that. Maybe that wasn't a great idea. Let's put that back. Maybe I can grab it. Nope, that's with me forever now. All right, can we reduce and should we? Yes, we should. You definitely want to reduce. So the 8 and the 16 both divide by 8. Or 2, you could do it by 2, but let's go straight to the heart of it and kill it. 8 divided by 8 is 1. 16 divided by 8 is 2. 7 times 2 is 14. 1 times 1 is 1. The answer for number 10, 7/8 divided into 1/16 is 14. You have 14 pieces that are this big out of a pizza that much. Let's try another one out of the Kaplan book. So we have number 18. Number 18 is going to have some fun and interesting things to do. So you have 3 7/8 divided by 5 1/6. Okay, so just like multiplication, we're going to make these improper. So 8 times 3, 8 times 3, 8 times 3 plus 7. 24 plus 7 is 31/8. Divided by, I'm not going to do the keep flip change yet because I don't want to confuse anybody. Let's make this one improper. 6 times 5 is 30 plus 1 is 31/6. Okay, now we're going to keep flip change. So we're going to scroll down a little bit so we have some room. 31/8 stays 31/8. That is the keep. 31/6 flips to 31 to 6 over 31. This changes to multiplication. And now what looked like it was going to be a really horrendously long problem is simple because these cancel out and both become 1. That divides by 2 and becomes a 4. That divides by 2 and becomes a 3. And 1 times 3 is 3. 4 times 1 is 1. And 3 7/8 divided by 5 1/6 is 3/4. Okay, so I hope that this helps. Again, multiplying and dividing fractions is not too bad. You do need to practice. If you're working on your multiplication tables, you need to memorize them because everything we're doing here requires that. And that is, that's all we're going to do. It should be good now. All right, good luck, and I'll see you during the next video.